Welcome back, amazing students, magic students, everyone. So we're on activity 4, page 311. We're talking about using unit analysis to convert units. This is super duper important for science classes, especially once you get to high school. Even I think 8th grade does it a little bit, but 9th grade definitely does it. I'm not sure about your science 8th grade. I'm pretty sure y'all do unit. I know all high school you do it. This is a big deal. We're not gonna go insane into it, but I would like you to at least see it once. So here we go. So we can use different methods to convert units, as we've already learned. We used ratio tables, use proportion analysis. We just use many things. You can set up proportion to scale up or scale down. You can also call the method called unit analysis, which is a form of mathematics. Super easy math, if you ask me, but some people don't find it easy. So I don't care about the details of that. I just want you to notice this example here in the worked example. 1 kilogram is 2.2 pounds. So I want you to notice the scaling up method that we've been doing throughout the year. 1 kilogram is 2.2 pounds. How did 1 become 4.5 kilograms? Because I'm converting to 4.5 kilograms. I just multiply by 4.5. Whatever due to the numerator, due to the denominator. This is something we've done before. No problems. This here is going to look confusing at first glance. I don't like it. I don't like how they word this one, but I'm going to show you a little bit more what it's like in detail. If you use a unit analysis method, in mathematics, there's a thing called unit math, where if you set this up, we already know 1 kilogram. Oops. We know, where is it? Here it is. We know 1 kilogram is approximately 2.2 pounds. I'm gonna put P for pounds. I don't want to use LB, it confuses. So if you're trying to convert this and we want 4.5 kilograms, the only way to do this is called a unit math. Unit math, well, not the only way, it's one of the few ways. In unit mathematics, what we're doing essentially, we're going to be multiplying the reciprocal of this to 4.5 kilograms. That will automatically give you the same amount. How does that work? Because it cancels out the units. Notice the reciprocal of 1 kilogram over 2.2 pounds is flipping it. Reciprocal is a flip. You have to know that key magic word, flip. So notice they multiply 4.5 kilograms to the reciprocal. Now, the reason why this works is because the units will cancel. Just like in fractions, if you have 4 over 5 times 6 over 4, the units here will cancel. Well, not the unit, but the number. That's the mathematics associated with it. The kilograms will cancel. When the kilograms are gone, all that's left is your pounds, which is what you were after. Now, why do they write over 1? Because there's a number, it's invisible under 1. You just multiply by the reciprocal. That's one way. The details of that is revealed more in science class, typically. Until you get about 8th grade, they actually do more details in unit mathematics. But it's a nice way to look at it if you wanted to do that way. I will show you in this example below. Just wanted you to at least see it. We're not going to go crazy about it because you will see it again a lot, especially if you want to do a science field. So both strategies use a form 1 to determine the equivalent number of pounds in a 4.5 kilograms. How is the form of 1 used in scaling up different from the form of 1 in unit analysis? I will show you. So 1 kilogram, 2.21 pounds is equal to 4.5 kilograms mystery pounds. Now, if you want to use this, let me draw an arrow to show you this. That's 4.5 kilograms. Because if you did this proportion ways, what would you do? You would cross multiply. And then you would divide by a kilogram if you did proportion way. Which is the same thing as you did on top on the other example. Notice the scaling up method. Let me change a different color. The scaling up method, you could just multiply by 4.5 and do the math. That's perfectly fine. If we did proportions, you would cross multiply, which we just did right here. I multiply the two numbers and then divide by the kilogram. That immediately cancels out the units. So that proportion technique you've been using, you've actually been writing it this way. You've been doing it this mathematics. It's just not written the same if you did proportion method. That's really the major thing. I just wanted you to at least see it one time. So the question was, how is form 1 using scaling up different from the form of 1 using unit analysis? You're really just not cross multiplying. You're just using a scaling up or multiplying by it's technically not called a like term, I forgot the exact word. You're multiplying by a value and scaling up to have equivalent ratios. And I just like to say using the proportion method. No, I'm not gonna say that. We'll change that. Come on, work for me, pen. And these, what's it called? A unit way. What was it called? Unit analysis. I need to eat, y'all. I have not eaten my banana or my sandwich. Unit analysis, we are using unit cancellation. That concludes page 311. We're going to move on to page 312. I need to eat my banana, I need to eat my sandwich. All right. A marathon is a long distance foot race with an official distance of 42.195 kilometers, 26 miles, and 380 yards. This is Christopher's method. This is Mac's method. Notice I see an up and down thumb. Explain why Christopher's answer is not reasonable. It's pretty obvious why his isn't reasonable if you just observe it. First of all, the units are not even going to cancel. There is no unit cancellation. Because when you do your math, your units are naturally going to cancel or you set it up as a proportion. So already kilometers and miles don't cancel each other out. They're different units. You don't just magically get miles. Units don't cancel. For Max's method, the units clearly cancel. The units are canceling. Most of the time you're on the right track. Some people still make mistakes, but majority of the time. Since the two units are canceling, all that's left is miles, then your final answer should have miles. That's why you're incorrect. Explain why Christopher's answer is not correct. Unit canceling is not correct. In number 3, explain what is different in how Christopher and Max set up their multiplication problem. What is important how they arrange the units and conversion rates. The units don't cancel. The same unit on numerator must be on the denominator. Number 4. Once again, I could do this proportion way, ratio way. There are just so many ways to do this. It's ridiculous. You could do this yourself. So I'm going to do the first 3, or rather, the first 3, and I'll have you do the last 3 on your own. Oh, I'll do the first 4 because Miss Christian's kind. Okay, here we go. So these are kilometers to miles is the unit conversion. That's what they're doing. How did 5 become 10 multiplied by 2? Whatever you do on the numerator, you do on the denominator. So that's 6.2. How did 5 become 20 times 4? That means 3.1 times 4. Which, oops, calculator's being dumb. 12.4. So how did 3.1, oops, okay, become 13.1? I have no idea, but how do I figure that out? Just do 13.1 divided by 3.1. That's about, that's an ugly decimal. I don't even want to look at it. I'm not going to lie to you. That is disgusting. It looks like it was 4.2258. I'll go with that, up to 4 decimals. So multiply this one by 4.2258. Don't be scared of the number. It's just a number. Oops. Oh, crap baskets. My calculator is being dumb. So that's about 21.129. Now, these last three I want you to do on your own. I'm going to check these in class just to see what you got. If you're wrong, that's okay. I want to see it on my own. But that's how you do it. Don't be scared of those ugly decimals because that's all you play with now. Miss Christian does not like decimals. First fractions. They're a lot easier to work with. Anyway, so that concludes page 312. Make sure you do those last three on your own. I will check them in class. All right, we're on page 313, our almost done last page. So in this problem, they're converting between US dollars and BRL, which I believe is Brazilian real. Oh, it says it. I can't read. What's wrong with me? So they said 1 US dollar is every 3.17 BRL. So 3.17. Just like when you go overseas over country, some of y'all been to Okinawa, some of y'all been places I don't even know, but I've been to many places too. But yeah. So we had to convert between dollars and whatever currency they had. Did Alejandra budget more or less than 500 BRL? Well, let's look at what she budgeted. She budgeted $500 US dollars. So we can set this as a proportion. 1 US dollar is equal to 3.17 BRL. We're trying to have $500. And I want to know how much BRL. Once again, you can do scaling up, scaling down, times 500, or do the division. It is up to you how you want to do this. Oops. I don't know what's wrong with my calculator today, y'all. Either that or I'm just cuckoo for Cocoa Puffs. I don't even know. So if I do my math, I get 1585 BRL. So did I budget more or less? Definitely more. I definitely budgeted more BRL. All right. How many BRL could spend in Rio de Janeiro? I might have said that wrong, but I'll try my best. I definitely did 1585. After Rio de Janeiro, Alejandro's family traveled to Mexico, where one Brazilian dollar was equal to 5.92 pesos. Okay, let's label that. 1 BRL is equal to 5.29 pesos. Alejandra has 295. So let's convert that. So 1 BRL is 5.92 pesos. And that's going to be 295 BRL. And I'm looking for the pesos. So let's do the math. Uh-oh. What's going on with my computer, y'all? So once again, you could multiply, do the scale up, scale down, or you could cross multiply. That is up to you, whatever way you want to do it. Okay, like I said, the computer is clearly being weird. My calculator's being weird. What is up with this thing today? 1746.40 is what I got. Pesos. That's how many pesos she'll have. For number 6, Emma is preparing to recarpet her room. She measured the room to be 6 yards long, 8 yards wide. I should probably highlight that. 6 yards long, 8 yards wide. When she got to the carpet store, all the measurements were in square feet. Very important. They told me the units are feet squared. That's an area that goes backwards. Area is feet squared, or I mean anything squared. Determine how many square yards. Ooh, they don't want square feet. They want yards. What is wrong with this thing? Work of carpet Emma needs to buy, recarpet her room. So they want square yards. Well, before we can do square yards, we need square feet. Okay, we need square feet. Area of a rectangle is base times height. So 6 yards times 8 yards. That's 48 yards squared. So that's yards. Determine how many. Oh, that's messed up. That's not yards. I totally wrote that. Oh, no, that is right. Oh, that's right. Okay, I thought that was crazy because they said yards. So they want to know determine how many square yards. That's going to be 48 yards squared. Area is usually feet squared, but it's anything squared, really. Determine how many square feet of carpet Emma needs. Well, if I have 48 yards, how many yards make a foot? 1 yard is equal to 3 feet. So we have 48 yards, and I want to know feet. And I know 1 yard, 1 yard is 3 feet. Once again, you can do scale up, scale down. It does not matter. That's 144 square feet. I'm not caring too much about how to check the answer because you'll be doing that over anyway with me in class. So that was a pretty good problem. I think y'all got that pretty well. So we finished number 6 on page 313. Now, the last thing I want y'all to work on, my magic students, we're not doing that top part. We're gonna go to the very bottom, complete each conversion and show your work. I'm going to do 2 of these and you'll do the next 2. So we should know this math here. I forgot how many liters make a gallon. I'm going back to my cheat sheet real quick because, I'll forget too, just like y'all ain't gonna lie. So I know 1 liter is approximately 0.26 gallons. I know, I'm looking for what's it called? Pounds, where are you? Pounds. Oh, that's the wrong paper. Uh-oh. Did I mix up my paper? No, I didn't. Okay, I thought I did. For a minute, I thought I mixed up my paper. So, also kilometers. What was it? Kilometers to meters? Oh, 0.38 kilometers to meter. Where's my paper? I don't know where I just put my paper. Oh, there it is. Okay. I'm sorry. Y'all had my stuff mixed up for a minute. Yeah, I'm going to have y'all do these. I want to write a little note for you. 0.038. So how many ounces make a pound? It should be 1 ounce is approximately 0.0625 pounds. For the inches, every 1 inch is approximately 0.0278 yards. And for kilometers to meters, for every 1 meter is 1,000 kilometers. Am I crazy? Yeah, mix that up. 1 kilometer is approximately 1,000 meters. I want you to do these. Actually, let's just have you do these 3. I'm going to do the first one for you because I'm kind that way. So I know 12 gallons, and I don't know how many liters. That's going to be about 1 liter, 0.26 gallons. So you can do the cross multiply method, just whichever way you prefer. Some students ask me, is it okay? Can I write it like this? It actually doesn't matter. It's just what you prefer. Just make sure, since you're setting up as a ratio, that gallons are on the denominator because we're not doing unit analysis way. That way, if you cross multiply, everything cancels out correctly, and that's about it. You could set it up that way or this way. It actually doesn't matter as long as the numerators and denominators line up. Is this thing okay? Oops, see, I'm not sure if y'all see it, but it's freaking out. So do your math. You can do proportion method. Why is it acting slow? What's wrong with this thing? So we can do 12 times 1, then divide by 0.26, which is about 46.15. And I'm going to put round to the second decimal. Actually, I shouldn't say that. Round to the hundredths place. I'm going to look for those 3 in class. Do your best. If you mess up, that is perfectly fine. I don't have an issue with that. I'm going to go over it anyway. All right, great work, students. I look forward to seeing you next period. Keep it up. Good work. I want to get Brewster bucks, so make sure you do your stuff. All right, have a good day.